All right, we will start this new tutorial series with a crash course in Godot. If you are here and actually don't want to follow along the idle game tutorial series but want a crash course in Godot, that will do very much. This is meant to be a general crash course. Eventually I will reuse it for any kind of tutorial series I make. I don't know if I do another version later, but anyway, we will try in less than an hour to see the most important concepts of Godot and scripting. So here I am assuming that you have never used Godot and have little to no experience in scripting. So if you don't know how to script, that will be taught here. The vast majority of the video will be the script section. So we will see basically what are nodes in Godot, how we organize nodes into scenes, and once we have a scene, we will see how we make scripts and how do scripts work with properties and methods. So let's start right away with the nodes. Okay, so nodes in Godot are basically anything you can think of and identify and isolate as an object. Sometimes nodes can be, let's say, more complex organization or structures of other nodes, right? So for example, here, if you look at this little list, every line is basically a node, which is a node displaying text. And if you take all those text nodes together, you can kind of structure those into a bigger node, which you could say this node is a list. And eventually you could bring this list in another big component, which could be a full document. So in order to make this clear, anything that you can conceptualize can be a node. As long as you can identify it as a unit, that can be a node. And even though it may have smaller units in it, well, it will be a node with actually smaller nodes to construct it. So it's kind of like playing that kind of, I don't know how to pronounce it in English, but those block construction games, Lego, where you have lots of bricks, which are primary color bricks or primary shape bricks, and you want to make something bigger, then you will just assemble some very basic bricks together until it makes sense, right? This is what nodes and scenes are. So a scene basically is a clump of nodes, but more specifically a clump of nodes where you have one root node which contains all the other nodes, because scenes are basically portrayed as trees. So if you look right there, which is the scene visualizer, you have a tree system where you have the root node and then you have children. Here we have one child, and this node here has 6 children, right? 6. So we could actually decide that this VBox container here is its own scene, as long as you can identify one node and say, this is going to be the root of a scene. That's all there is. Like even this label 3, we could decide to save this branch as a scene and it would become its very own scene. Okay, so let's get rid of this content table and start creating something. So here we will be using user interface nodes, okay, because they have colors. Okay, let's check the list. Actually, they have colors, and the blue one use the 2D rendering, the red one use the 3D rendering, and the green one use the 2D but interface rendering, basically. So there are a ton of nodes that you don't need to learn right away. What I suggest you to do if you're beginning is to basically watch well explained tutorials, and you will actually learn about nodes by basically having people tell you what node to use. At first, in my opinion, it is the best way to go with learning the nodes, because you will get to know the most common nodes and how they're used, and if the tutorial explains properly why use those nodes. Once you are more comfortable with understanding how nodes work, then you will actually be able to watch the kind of videos which are like explaining how nodes work, right? They are very good videos about this topic, and then you will be able to actually dig in the Godot documentation. This way, you will be able to see if, well, you will be able to actually look at what a node does and think, oh, this could solve these kind of problems, right? So don't rush it, just go step by step. So yeah, what was I saying? That we want to make a user interface? Yep. So here, we'll just use a green node, and by default, Godot gives you that green control node. A control node is I'm going to say a category of node, which is basically all the green nodes. All the green nodes are control nodes. Another way to say that is that all the green nodes are more complex version of control nodes. And actually, I'm going to talk about extension or inheritance right now, because it's actually very easy to visualize it. In Godot, all the objects which are created, so either those which are created by default with the language, or those that you create yourself, they can be a more complex version of another object which already exists. So here, let's create in this control a child node, which is going to be a button. And I want you to look at this inspector here. So here we have the scene tree visualizer, and on the right we have the inspector that shows us the actual content of the properties of one node. Okay, so here the button node, it is a green node, right? So because it is a green node, it is a control node. And if you look here, you actually see categories. Okay, so here you can see that this is a button. Okay, and buttons have a set of properties, but buttons are an extended version of base buttons. They actually share all these properties with all the other base buttons, other base button nodes. But again, all the base button, they actually share the control properties, which are right there. And all the control nodes, they share the canvas items behaviors, which again, canvas item, they are themselves nodes. So this concept of extension is actually able to create different nodes which share same behaviors. Okay, so for example, one of the core behavior of nodes is to be able to be added to the scene tree. So because of that, everything that you want to add to the scene tree must be a node in the first place, because it's actually part of the behavior of nodes. All right, enough talking about what those are, and let's actually create a scene. So creating a scene is basically just assembling nodes together to make something that makes sense. So here we will make a simple clicker with a button which allows you to create some kind of results. So here we already have a button, it's great. But I can already tell you that we will need to be able to visualize the amount of results we have. So we will also need to add a label to display text. Great. But let's begin with the button right now. So first, you actually want to check that when you are in your control node here, that you correctly have the entire screen highlighted in orange. If you don't have this, you can go within this little button here, which is anchors, and check the white square full rect. We will explain this right away with the button. So now that we have a button, it is actually very small, because again, the blue rectangle here is the screen. And the button is not positioned and very small. So what we need to do is basically to give it a position on the screen and a minimum size or an actual size. So those are properties of the node, which you can change to basically move it. So I guess you can just, drag and drop with the buttons. That's something you can do, right? You can make it bigger and move it. That's something you can do. But on the long run, it's very inefficient. So I actually want you to look right there. In the inspector on the right, if you go in this control category, which is again shared by all the green nodes, you can go in the layout block, and in the layout block, you will find this transform. In transform, you have size and position. Okay, so here, both, they take an X and Y value. So X is the horizontal axis and Y is the vertical axis. So it goes from this point here, which is 0. Here you have the positive, here you have the positive, and negative, negative. So the position is basically the distance between your object and the origin, which is this cross here. So you could manually say, I want my button to be 23 pixels on the right and 25 pixels on the bottom. But again, it's not so easy to actually position an object like this. So Godot comes in with a system of anchors. Anchors you can change by selecting the right node and clicking this little button here. You will have a lot of anchors presets. Or another way to change the anchors is to go there in the layout of the control. You have this layout mode, which you can change to anchors. And then you will be able to change again the layout. So here, this little button, we will make it at the center of the screen. And by using this anchor center, it is automatically centered here. Now, as for the size, we can actually manually choose the sizing here with those values. So what I'm going to do is just use a 320 horizontal and 80 vertical. This is going to be the size of the item, and I'm just going to check the anchors again, because changing the size like this can mess it up a little bit. Alright, so now my button is properly positioned here, and I will just finish it by still in the inspector, just add a little bit of text to say what it does. So for this crash course we will be generating let's say gold. Yeah, so this button will generate gold. So now we do have a button which we can click. So we do need to add a label which will display the amount of gold that we do own. So again, we need to position this object. So I'm going to use an anchor and choose a center top. All right. And now I can type whatever I want within this text. So here I just added a random value of gold, which is 25. And that's pretty much it. Okay, so we have this. If you do want to make this label a little bit bigger, you can change the label settings, but there's actually an already done thing for that. We can go in the theme category of control and use the theme variation header large. So editing theme is something which you can do in Godot, but we're not gonna talk about that here. We're just gonna use this theme variation, which is a built-in variation to make things bigger for labels only. So anyway, here we have the scene. Okay, so we do have a button, we do have a label, and we can actually run it with this run scene button at the top right, and we actually need to save it. Sorry about this. So let's save it actually. I will create a folder scenes and create again a folder clicker and then rename the file. So Godot doesn't come with a folder structure, so you kind of have to come with your own. Again, this you will learn by watching complex tutorial where people will actually show you their structures and how they do things. So do not worry too much about this, and actually be wild and experiment as you think it makes sense, right? You could have very good ideas. So anyway, here let's run the scene, and there we go. Here we have the window, we have a button which we can click, and we have a label. The problem is that it doesn't make any sense yet, or it doesn't do anything else than having a button which can be clicked and having a label which displays something static. So this is where we will be using scripts. So now that we actually saved our clicker here, I'm just going to rename the node, and I will be able to add a script. You can add a script by using this button here or right clicking, it's up to you. And you just need to save this little script that they give you by default. It's very good. On the long run, you will want to choose probably where you want to save your script and stuff. I usually like to keep the scripts within the scene folder where they belong. Before we actually do the script, I want to talk about something about attaching scripts to nodes. Scripts are attached to nodes, which means that it does have an impact. It does have an impact in the ideas that the script in the scene tree, it is run from there, and for some methods they will be triggered based on this node that you have attached the script to. So, for example, you could attach a script to the label here, and the script would be able to change all the things in there, like the goal, for example. But since the script that we're going to use is attached to clicker, it will be necessary to access this other node to be able to access the script of the node. Another thing which is quite important to understand, every node by default has its own script. You could say so. Here we have a control script, here we have a button script, and here we have a label script. The point of attaching a script here is to actually extend whatever is already in. So when we add a script, there is already a bunch of functionalities within the script which are hidden, but we're just adding some logic on top of that. So if you actually do want to see that, you can control click on any type, and that will open the documentation, and here you can see all the properties and all the methods which are contained within the control script, which are methods and properties which this node can use and will use. At the very top you have the list of inheritance, so you can see that a control node actually inherits from canvas item, which again has its own list of functionalities, and node which has its own list of functionalities, etc., etc. So when we create a script, what we are doing is we are adding another layer to that, and that's pretty much it. So scripts can be anonymous, but it's a good practice when it doesn't need to be anonymous to actually have a name which can be declared by using class name. So class name, because basically in the language of Godot, in every object-oriented programming language, a class is the blueprint of an object. That will make more sense later. So now that we have named the script, we have this extends control here. So this line, when you attach a script to a node, you can't get rid of it. You have to have this. So for example, if you actually attach a script to a button, you will have extends button and label extends label. Great. So now that's it for the script creation, but how do you actually fill that script? Well, you will use properties and methods. So a very simple way that I look at properties, let's start with properties. A simple way I use to look at those things is to think of properties as boxes. There are boxes which can be labeled or have different shapes, and those boxes can contain value. One box, one value. So what we do in a script is that we will basically create those boxes, put things in those boxes, and then we will manipulate those things to create whatever behavior we want to see created. Then we have instructions. Instructions are basically just a line of code. And they are, let's say, they are anything you can do in a programming language, right? So the interesting part of scripting is that if you really look at a script, I just want to remind you that we say a programming language, right? And language is very important because a script, you are actually able to translate it from one language to another. So here we are speaking English, and you can actually translate one to the other. So for example, let's say that here in our situation, we have the label gold. If you want to be able to change this box, then change this value, you need to know what you're talking about. So basically, you have to say that the box containing the value of the label displaying the gold value, it exists. So this is what we call declaration. We basically declare and tell the user or the engine that some boxes exist and they can contain data. So in another way, here, if we want the script to be able to impact and manipulate anything, we have to declare it first. So we need to declare everything that we want the script to be able to manipulate. So here we have the label, we have the button. All those are things that we want to change. But it doesn't end there, because we do have as well the gold. The gold here, the value of gold that the player owns after clicking on the button, is kind of a hidden thing, an implicit object, but it exists, okay? And it is actually a different thing than displaying the amount of gold, right? So what I mean is that the amount of gold is different than the label that shows how much gold we have. Because here, it will contain the value, the numerical value, and here it will contain the text value that we want to display on screen. Alright, so what we do now that we have basically understood what boxes we need, we declare those variables or properties with the var keyword. So we will have a label, we will have a button, and we will have gold. That's all you need to do to actually declare variables. However, it doesn't end here. Because as I said, boxes can have different shapes and they can take different values in. So in programming languages, there's something that we name types. Types allow you to basically say the engine, this box, which I named label, right? This name, basically, it's up to you to choose, right? There's no limitation. Well, there's some about the way you name those, but aside from letters and numbers at the right position, you can say whatever you want. But the types, though, they are very clear. So here, let's say that this label, I want to tell the engine that this is going to be, well, containing a label like this. So you can assign a type by using a colon and declaring the type that you're using. So here the nuance is that the variable name takes a lowercase, meanwhile the types takes an uppercase, right? As you can see, label, control here, And even clicker, they have uppercases, which means they are types. Here we have a lowercase, so this is a box. This is a value. So in the same line, button is a button, but gold is not a gold, right? Because gold is a floating value, implicit value, and it's a number. So numbers in Godot, and in actually many languages, they are what I usually call basic types or primal types. They are kind of the most primary building blocks you have. So in Godot, the numbers are actually very easy. You have integers, which are int, like this, and you have floats. So integers are, well, integers, and floats are decimal numbers, which can go way higher than integers, I think, if I remember correctly. But anyway, here we want gold to be an integer because we don't want to have half of a gold. So now we have declared those boxes. And now that those boxes exist, we can actually put things in those boxes. So adding something within a box is assigning a value. So this is an instruction as well, right? Declaring a value, a variable. Declaring a variable, that's an instruction. So here we have 3 different instructions. But we can assign values. So assigning a value comes in the form of using the equal sign. So here we can actually declare a variable and assign a value to it at the same time. That works. But we can only do it for the gold, which we will initialize to 0. So again, here I say that we have the box label, I say that we have the box button, and I say that we have the box goal, and that goal I will actually put the value 0 in it. Here, those boxes, they are empty at the moment. The reason why, I will explain in a few minutes. First, let's now talk about functions. Functions are recipes of instructions, lists of instructions, or blueprints of instructions. So basically, writing a function is all about writing instructions that you actually want to be able to reuse as many times as you want. There are actually 2 types of functions or methods. You have those which you create yourself, and you have those which are built in the language. The built-in methods are basically those which are contained within the documentation. So here, all these are built-in methods that we can use if we need those. But we can create our very own. Now, to understand how to use basically functions and variables, we kind of need to understand how the game is processing things. So there are lines, there are instructions which are hidden, which we do not control really, which will basically create everything in the scene here. Okay, so if I run the game, as you can see, the engine has generated the label, the button, position things, and stuff. So we have instructions which are being triggered without us having to say to the engine, please trigger those instructions. However, we can kind of insert our very own instructions in the middle of those already created instructions. So for example, here, I'm gonna use this ready function like this. Declaring a function is basically using the keyword func. Then you have a name. It doesn't have to take an underscore. It has to take basically a lowercase. Then you have parentheses, which are taking the extra informations named arguments. Here we have an arrow, which basically is used for the type of the function, which is telling us whether then at the end of its instruction list, it should give us a value or not. Some functions do give us values, others do not. So here, the type being a void, which means void, it doesn't return anything, so this function just goes through a list of instructions and doesn't return anything. This little pass here is just to please Godot, because Godot doesn't like empty functions, so you just have to put some placeholder in it. Alright, so the point of this function ready here is basically that it is automatically triggered by the game. This function comes from nodes at the bottom right. Every node have this ready thing, ready function. And basically, whenever a node is ready, you can do whatever you want on top of what already is. But what does it mean for a node to be ready? We talked about scenes. So nodes are structured into scenes. When a node is added to the scene, it will get ready. But for a node to be ready, we actually need its children to be ready. So in our situation here, when Godot will run the scene, it will add the clicker node to the scene tree. Okay, but adding the clicker node, it does add all its children at the same time. So it will add clicker, button, and label. Okay, but then when a scene is added to the tree, it will get ready once it is fully done. So what it means is that it's not click a node, enter the tree, and is ready, then button node, enter the tree, and is ready, because ready means that it is ready. And if here we have the clicker node but not the button and not the label, how can it be ready, right? So it actually goes down when they enter the tree, and then it will add everything to the very last node, and then they will get ready one by one backward. So button will be ready, then label, then clicker, and whatever is above that. So here, this is a built-in method that we override, which means that we add content or instructions to it. We override it to say basically that when the node is ready, what do you want to do? Okay? And this is where you will actually put your own instructions, right? Because this is where you will weave in your instructions that will make the game running. So why did I say previously that here we can, by default, say that gold is equal to 0, but we can't say what is label or what is button? The reason for that is because of the node added to the tree and ready thing. This part of the script is used before the node is actually added to the scene tree. So this is calculated while the node basically isn't a node yet. It's just a script. So 0 is a value, numerical value that does exist in the scope of the script just being a script. So it does know what 0 is. But if the node clicker isn't part of a scene tree yet, it can't know what either button or label are. Those two things, well, it knows what the types are, but it can't know what the actual objects you want to put in the box are. So you actually have to wait for those things to be constructed as a scene so that you can, when the node is ready, say, all right, now I will put this button here in the box button and this label here in the box label, right? So this is why we have to wait and put the instructions at the right place. Before I put those, I just want to say that I like to organize my functions very thoroughly. I appreciate my functions basically having one job that is described by its name. So here, this base function, which is ready, what the name implies is it does what it has to do when the node is ready. But everything I can kind of scale down, I will, okay? So for example, here I want to put the button and the label there in those boxes here. That's one job, which is assigning the values to the boxes. So what I will do is I will create another function, which purpose will be to put the values within the boxes. And then I will have the ready function call on the other set of instruction. So we can describe another function, which I will name get nodes with an S, which is going to return nothing and do nothing at the moment. I actually take this moment to talk about indentation. GDScript, I often say Godot, but really I mean GDScript when I'm talking about the scripting language. GDScript works with indentations or tabulations. So what it means is that here with the colon and the func line, we are describing and declaring a function. What defines the beginning and the end of the function are basically the indentations. So here we indent to say that the function started, and as long as we are indented, we are within that block. But as soon as we get back to the origin, then we are back to the main script. Here, the main script is only declarations, right? So if I translate what we have here, the script basically is I'm creating a box label, I'm creating a box button, I'm creating a box gold, and I'm creating a recipe to execute, which is this one, and I'm creating another recipe to execute, which is this one, but none is executed yet. That will come with the hidden instructions of Godot. and basically the scene being constructed. So now that we have declared functions, we can actually create instructions that tell us, I want to run this set of instruction. So you just have to use the name of the function and the parentheses. So again, at the moment, nothing changed within the script, but what will happen is that when we're ready, we go through this node, this function, sorry, which tells us, okay, go run the instructions in the function getNodes. And here we do nothing. All right. So what we want to do here, if you remember correctly, I want to fill those boxes, label and bottom. So in order to fill a box, just like we did with gold, we have to get the name and use the equal assign operator. So I want to assign something to label. So I use the name label and use the operator equal. We do not use var again. The var keyword or the function keyword, they are here for declaration, to create the concept of something. Once it is created, we don't need to create it anymore. Instead, we reference it with its name. So here, now that we have this assign operator, we actually need to grab the value or this object. We need to grab this object to put it in the box. So here I'm just gonna make a little shortcut. We're gonna use a method that comes from the node object. That method, I will actually show it to you. Here, let me watch more precisely. We're gonna use this one, which is getNode. Like this. We're gonna use getNode. GetNode is a method that allows the script to get the information from a node somewhere and put it in a variable in a box. Here, the parentheses, they are not empty because they do take information named argument. They do take an argument, which is the path to a node. And here the little node thing is the return type of the method. Okay, so in the script it would look like this. It would look like getNode, it takes a path and it returns a node. This is what it looks like basically. But it already exists, so we don't have to declare it and type it. So what we're going to do instead is just refer to its name. And now we need a path. So here we have the auto-completion. So you have to be careful with those because you need to find the right path. But just to show you, because it is a very useful thing, you can use the unique names for nodes by right-clicking and using the access as unique names. I would say that the prerequisite for having a unique node is that basically it has to be unique, as in only one does this. Otherwise, you would have to result on other systems than the unique names, but anyway. So what it means is that when we actually get the node like this, we can use the % and the name of the node, which is here label, and it actually doesn't matter the path of the node as long as it is within the scene. No matter where it is within this scene here, it will find it, basically. All right, so here we have this line. We take the box label, we assign something to it, and we use a built-in method from the nodes to actually go get this information and put it in a box. Just to make things, I don't know if this is going to be clearer or more confusing, but what's happening here when we put the label in the box, we are not duplicating the data or the object. We are creating a reference to that object. So here, label is a reference to the label here. So if we change the label that we have within the script, it will actually change the label which is at the end of the reference, which is this one. Okay, I just want to make this clear because I don't want you to think that when you assign an object to a variable, you actually create a copy of it that you can change and will be independent. This only works with primal types. By the way, I just realized that I didn't go through all the types, but I will do that later. So here now we can do the same behavior with the button. We would get node and we will get button. Okay, so this is done. So now we actually are aware of our label, our button, and the goal value. So it's all a matter of manipulating those values within those boxes to get the behavior that we want, which is increasing the number here when we click on the button. So we will actually start by resetting the value to 0 when we start the game. So obviously we could just go in the label and put a 0 here, alright? But we are here to learn, which means that we will do it with the script. So we will create and declare a new function, which is going to be update label. It won't take any argument and won't return anything. But what it will do is change the values within the label here so that it changes what is displayed on screen. Alright. If you remember, I've talked about primal types, which are basically integers, floats, or numbers. Text is a primal type. Booleans, which are true, false, binary values. But we have complex types, which are objects, basically. And this label here, it is a complex type. So what I mean by complex is that it is a structure of simple types or primal types into a complex one. So for example, if you look at this label and all its properties, you end up with primal types. So here you have text. Here you have, well, an object, which again will be primal later on. Here you have an integer, an integer, an integer, a boolean, 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 etc., etc. So what we want to do is basically change this text here, which is part of the label. So the way you actually modify an aspect of a complex object, but you just want to target one property you want to change, is by using I don't know how, there's probably a name for it, but basically you will be accessing a property within an object. So maybe the name is accessing, but if you want to access a property within a property, right? So in other words, if you want to access the text within the label, you use a dot, right? Which means you go in the label to find something more precise, more refined. But what is the actual name you use now? You need to know the name of the property that controls the text being displayed. There are different ways to do that. The first one is to hover here in the inspector over the name, and you have this little property colon text. So now you know that this text, which is bold and underlined, it is the name of the property. So here, if I type text, the editor confirms that yes, within the label, there is indeed a text that you can change. The other way to find properties is to Control-click or use the help and basically go in the documentation to find those properties. And here we do indeed have text right there, which displays the text on screen, and it takes a string. So back to the script, it's here. It actually takes a string, so we can assign a new value to it, being here. So here it's going to be gold 0. So right there, as you can see, strings are between apostrophes. I think it's the word. But that's just plain text, right? So how to put that? If the gold value would change, the text would still be 0, no matter what the gold value is here. So there are many different ways to basically use the other value in this text here. So the easiest way to understand it, I guess, is to make an operation, because even though it may seem weird, you can use mathematical operations on strings of characters. So here we can basically just add the 0 like this. So you have the gold equal, and then at the end you add the 0. Okay, now that we have the 0, we want this to be based on this value here. So there's a little method which is str, which allows you basically to give it an argument number, and it will transform that number into a string of character. Okay, so this is the easiest way to understand it first for a beginner, but this is not what people use. I mean, there's many things I do here that people shortcut somehow. But basically, you can directly choose not to add it at the end of the string, but to insert it within the text itself by using a percent operator. So you can basically say that gold. You have a percent within the text and outside of the text, and they basically mirror each other. And what is on the percent outside of the text will be added within the text exactly where the percent is. Not done yet. Gold is an integer. You can't put an integer within a string. So we do apply a conversion of type, and here we're using the keyword s to remind us string. And it reminds string, it mimics, it mirrors string. So this little thing here is basically saying that I'm bringing within the text at this place exactly the value gold that I'm transforming into a string. And then you can put other things in there at the end. It will insert it exactly where the % is. It's just lucky that it's at the end here. So anyway, now we do have a function that basically updates our label to display the current amount of gold that we own in our implicit box. So what we will do is just add this instruction in the ready here, so that when the node is ready, when clicker is ready, which means when the scene is ready, we will update the label to match whatever gold value we have. So we can now start the scene and have gold 0. Okay. Now that we have this, we can click on the button, still doing nothing. So here, we basically need to understand or to catch whenever the player is clicking on the button. So we're going to talk about signals. So here in the editor, on the inspector, you can basically go in this node tab and you have groups and signals. So signals, basically, they have a very good name because nodes can emit signals at different times. For example, can I get away from the view? The auto frame is putting me back. So here we have a list of signals for a node, right? So when a node is ready, it emits signals. And we can do something about it. It's not this. It's a little bit different. For the button, we do emit the signals when it is pressed, which is exactly what we want, right? We do want to know when the button is pressed to do something. So what we can do in Godot basically is connect signals with methods or functions to say that when the signal is emitted, we do want a function to be triggered as a reaction. This is how we catch user inputs, basically. So we do have the button in a box, and we know that the button has a signal. So if we just watch the tooltip, we know that the signal is named pressed, exactly like here. So what we want to do is to basically connect the signal to a method so that the method triggers when the button is pressed. So I will create a new function, which I will name connect signals. So again, this is just a method that I created, and in there I will fetch the button within the box, access its properties to find pressed. Okay, so now we do have the signal. What we do with it? Pressed has a method connect. So there is a method within pressed which I can use right here. So again, to access this method, I will use another dot and find connect. Okay. So connect as a method, it takes an argument. Where is it? It's right there. So here, this method takes a callable, which is basically the type of a function or a method, and it takes a flag. The flag, as you can see, there's this equal 0 here. So you don't necessarily have to specify one. You can, but you don't have to because there's a default value. So here we only care about giving the function that we want to connect. Here, this method, it returns an integer that we can use, so it returns information. However, I'm choosing not to use that information, so it's going to be discarded. So back to our script, here, we actually now need to specify as an argument whatever I want to do. So we said that here we basically give a function as an argument. However, what function? We don't have any. All right, so let's create a new function, which I'm going to name on button pressed. At the moment, it will do nothing, but now that it's created, I can basically put its name right there. So it's a little bit weird, but we don't put the parenthesis after the function here because we don't trigger the function. We just make a reference to the name of the function. All right. We have not to forget that we want to connect the signal sometime. At the moment, we just have the method connect signal, so we need to trigger it when the scene's ready. Okay, so now that we have this little thing here, when the button is pressed, what we want to do is to increase the implicit amount of Go we have. So I'm going to create a new method again. Here we have generate gold. So this will modify the gold value. So I'm going to take the box gold and I will assign a new value to it. The value I want to assign is basically the old amount of gold or the current amount of gold plus 1. So it is the current value plus 1, like this. I'm assigning gold plus 1. You can shortcut this by saying plus equal 1. So plus equal is an operator that says I want to add this value to the actual value. This is what you will see very often. Okay, so now we're going to see and test. Maybe you actually know what is missing because something is missing right now. Well, on top of having to generate gold whenever we press the button, right? Because if I go in the scene right now and click, I do change the value in there, the floating value, but the label doesn't reflect this. So the simple answer is that whenever we actually change the gold value, we actually want to use our update label method to again make sure that the label is displaying the new amount of gold. So now we can actually click and successfully change the value of gold whenever we click. And that's it. we are actually done with this tutorial. We actually have seen how to make many things, how to structure nodes together. We've basically just talked a little bit how to position and size the nodes, and then how to make a script. So I decided in this script to actually do everything within the script rather than using the built-in features of the editor. And I will tell you exactly what you can do within the editor without having to put a line of codes in it. All right? So those two lines, get node label and button, you can simplify those by using an export tag in front of any property. And once the export tag is set, you can go in the node here. It's the node with the script. You go in the inspector and you have a new category, which is the name of your script and the properties that you do want to set. So you can assign label and you can assign the button. This is a way to get those nodes within those boxes. All right? Then this signal connection here, you can actually go on the button, find the signal pressed, right click and connect. And there you will be able to pick a method within the script you are selecting by choosing the node. So in the clicker node, I will pick on button pressed or whatever method you want to be connected to. And there you go. You can go with OK. This will have a green arrow. Well, actually, I will just do it like this. So you now have a symbol displaying this entering here and exiting here. All right. Are there other things we can do in the editor? Nope. You might be wondering why I actually chose to show you how to do that without using the editor features, because the editor features are meant to be helping you understanding or doing things faster. Why I do agree to a certain extent. First, I actually want you to understand how those methods work, right? Because when you're using an editor feature, it's important to understand what's happening behind it. If you are scripting, those features are first and foremost for non-programmers who actually need to have things they can edit and change without having to go in the code. For example, here, the value gold, you can export it so that in the inspector, if anyone, a game designer, has to change the value gold, they can do it here without having to change it in the script. Okay? The second thing, which is important, is that you have to set up your exports and the way you use export things properly so that it actually works when they are manually edited there. All right. The third reason, and most important reason, I think, is that sometimes you will be working with objects or nodes which you won't be able to manually design in the editor. Very quickly, you will want to instantiate nodes through the script. And those nodes that you instantiate, that you create, you will have to be able to get nodes, connect signals, without right-clicking in the editor. I'm going to give you a very simple example. You have monsters spawning on the map, and you have a monster counter at the top of the screen, and you decided that in order to update this counter, you will make signals that when a monster spawn or when a monster despawn, you want to increase or decrease that counter. So now, there isn't a programmer right-clicking and adding child, adding monster like this. No. That's the game running. So you have to be able to create functions which will create nodes, add nodes to the tree, and connect the signals as those nodes are being added to the tree. All right? The fourth reason I'm using this system is that at the moment I've decided for the tutorial series to not use any editor feature like export or connect signals, because I want all the things to be written visually, so that any viewer that just sees the script is actually able to understand all the things that happens. Because if we have an export here, you see the export, but you don't see actually which node is within the export. If you just see this little green thing here, which says that this is a signal connected, you can't know which signal is in just by watching it. Of course, you can click here to find out, but anyway. The fifth reason is that I'm a script guy, and it's actually way easier to me to find where there's a problem and to understand the logic of a script when I have this line, because right there I know that I'm taking the button, which comes from the bottom here, and I'm connecting on button pressed, okay? While when I'm just there and scrolling through the script, what I see is on button press, I can guess it's triggered by this button because it is named properly, but I'm not so sure, and sometimes it can be a little weirder than that. Okay, and also right there, I know for sure that the button's connected because it is visual, right? Because, for example, you could have this little symbol missing if it is not manually connected through the editor. But you could just not see it because it's just a symbol. It's very easy to miss it. So anyway, that's all you need to know for the reasons, I guess. So that's it for this crash course in Godot. I'm just gonna end this by showing you a few things that are interesting to know, and we will be done. So here in the editor, which we've used, we have the file system that we've barely used, but that's where you will structure your files. You can use colors to make your folders differentiated. That's very interesting. Here in the middle view, we have either the scene rendering or the script editing based on whatever you want. All the scripts open. Here you have the different methods within the scripts, which allows you to navigate faster. Right there, you have a few interesting functions, like for example, search, which allows you to search, especially in different files. At the bottom, you have the console, which you can use for displaying many things. You have the debugger that we didn't use, but basically this allows you to help you fix problems. You have a few other things which are not very important right now. In the inspector on the right, you do indeed have all the properties of whatever node you're currently inspecting. You have the node tab with the signals and the groups if you want to group nodes together to make it easier to manage your nodes. Here you have a history of everything you've changed. And right there you have the scene tree with this little input tab, which allows you basically to modify the properties of any asset you are importing. For example, their types, which can be handy sometimes. So yep. At the top, you obviously have those editor buttons and whatever you need to start a scene or the project. All right. That's it for this crash course. I hope you liked it, and that if you are very new to Godot, that you enjoyed it, and if you did watch this, even though you are experienced, you did find interesting thing, right? Because I want to say that even intermediate scripters, which are, well, no, that's gonna be beginners, but there's still things you can learn in there. Well, anyway, doesn't matter, you've watched the video anyway. So yeah, hope you like this and that you are actually wanting to see more with the tutorial series that will follow, and I will see you later.